is Mrs. Often, and today we're going to talk about systems of equations. You've studied systems of equations before in Algebra 2, so we're going to review these, and we're going to talk about methods for solving them, including graphing and using substitution. We'll also talk about nonlinear systems of equations. First, some definitions. A system is a set of two or more equations in two or more total variables. An example of a system would be x plus 2y equals 6, and another equation, negative x plus 3y equals 1. These two equations go together to form the system. Even though in this example both equations have two unknowns, it is possible to have systems that have an equation with two unknowns, one equation with three unknowns, and one equation with only one unknown. So as long as you have at least two equations and at least two total variables, you have a system of equations. A solution of a system of equations is a coordinate point that is a solution of all equations in the system. So a solution point has to work in both of these equations in order to be a solution. Can't work in just one of them and be a solution of the system. Is it a solution? Well, in order to figure out if something is a solution, we will have to check. Again, a solution point must work in both equations. If there's more than two equations, it has to work in all of them. Be cautious, sometimes you'll only have to check for, say, one variable. Like if I have x plus y equals 3 and y equals 2. If I'm checking to see if 1, 2 is a solution, in this second equation I can only substitute the y value. So you should recall that from your studies in Algebra 2. On to our example, we're going to verify that 3, 1 is a solution of this system. 2x plus y equals 7, x minus y equals 2. So I'll substitute 2 times 3 plus 1. Is that equal to 7? 2 times 3 is 6 plus 1 equals 7. So yes, that is a solution. Once I verified that it's a solution for one equation, it's okay to go on to the next equation. If it doesn't work in that first equation, why even bother checking? It's not going to be a solution of the system. So now I'm going to do 3 minus 1 equals 2. Hey, that works too. So 3, 1 is a solution. Remember, again, if it doesn't work in both equations, it is not a solution. Now, solving by graphing is one way of solving systems of equations. It can be used for both nonlinear and linear systems. I think it can be better if you have nonlinear systems because that might be harder to solve using substitution, or the method that appears in my next video, elimination. Also, it's good to use when things are easy to graph, or if you have technology like a graphing calculator or a computer algebra system to use. Also, it's useful if you just need an estimate. So if you just need an estimate, then this can be a good method to use. Let's look at an example of solving by graphing. You see here that I have a linear equation and a quadratic equation. Now, since a quadratic equation is a parabola, a U-shape, and a linear equation is a line, they could intersect in 2 points, or in 1 point, like at the vertex of the parabola, or it could be that they don't intersect each other at all if the line was totally below the graph of the parabola. Let's see what happens. So I'll graph one in green and one in black. First, I'll graph this. 3x and 2y, let's see if I put in 0 for x, then y equals 3. If I put in 0 for y, then x equals 2. Okay, so I'll graph both of those. Okay, and I can see that that's my line. Now, graphing in black, I have y equals x squared plus 3. So I have x squared plus 3, 1 and negative 1, so 4, 2 and negative 2, it's at 7, 5, 6, 7. Redrawing that a little. So you can see this is why I suggest having technology. Now I can see that my graphs definitely intersect here at the point 0, 3. I can also make an estimate that my graphs appear to intersect at the point, this looks maybe like negative 1.5. So let's see, if I were to put negative 1.5 in here, I would have negative 4.5 plus 2y equals 6. So 2y would be equal to positive 10.5, and so that would be equal to approximately 5.25. So negative 1.5, 5.25, approximately. This is an example of a time that I would be getting an estimate. Using technology, as we will in class, will help us to better estimate and better determine the points of intersection of linear and nonlinear graphs. Again, solving by graphing, good if they're easy to graph, and you just need an estimate. Another option is solving with substitution. Now, solving with substitution, you can use for nonlinear systems. You can also use them for systems that are harder to graph. You should only use them when it is easy to solve for one variable or one unknown in each of the equations. So we're going to look at an example where solving with substitution is a good idea. Okay, and please ignore the fact that all of my posters are falling over. So here I'm going to solve this system with substitution. You'll notice that both of my equations have been solved for y already. This makes it especially easy to substitute. I'm going to replace the y in my second equation with this 2x. So replacing y with 2x, I'll get 2x equals x squared plus 1. Now remember, because this is a parabola, x squared plus 1, and 2x is a line, I could have 2 points of intersection. So let's see if that happens. I'll solve this quadratic equation in x, first subtracting 2x from both sides, and then I'll factor. It appears that I got the same factor both times, so that indicates to me there's just going to be 1 point of intersection. Setting the first factor, and in fact the only factor, equal to 0, I'll get x equals 1. Okay, so if I substitute this into either one of my equations, so it looks like my single point of intersection is going to be 1, 2. Let's just check and see if this also yields an answer of 2. So I have 1 squared plus 1, y equals 2 here as well. So my single solution point is 1, 2. The line y equals 2x intersects the graph of y equals x squared plus 1 in 1 point. So that's two straightforward methods to solving systems of equations that are especially useful for nonlinear systems. These methods again, graphing, either by hand or using technology, and the substitution method. Look forward to my next video on solving linear systems with the elimination method. Thanks and have a great day.